Hi, I'm Harshit, and along with my collaborator Rob, we're going to talk about Protopiper. So Protopiper is a handheld fabrication device, and it allows essentially for three key things. It allows for physically sketching room-sized objects at actual scale. Wait, sorry.
Okay. It's interesting. Okay.
Yeah, okay. Let's do this again. Okay, so Protopiper, it allows for three key things: physically sketching of room-sized objects at their actual scale. Yeah, it's working now. So what we take as input for this device is a roll of tape, and what we give as output through this device is hollow tubes, which are lightweight and sturdy. In addition, we have cutting mechanisms that help you make connectors, and all these together help you to actually sketch large objects in the real environment. This is the device, and this is how it functions. We'll talk about this in detail as the presentation goes on. Okay, so this is Rob actually sketching out a sofa in his living room. And yeah, as you can see, he sketches out the sofa in the actual size so that when he later buys the sofa, the real sofa, he's happy with the results that he's got. Okay, taking a step back and starting from the beginning. So in the field of human-computer interaction, handheld fabrication devices are becoming popular. Here's an example that we show, which is the 3D, which was presented at UIST around 3 years ago. Wonderful project. This deals with subtractive manufacturing, so you remove material to create the desired output. This is the 3Doodler. It's a commercial product. In some senses, our project is aligned to more sort of this additive way of fabrication, where you take material and sort of stack it up to create output objects that you want. And you design as you go along, which is a process we will refer to as sketching. What this allows you to do very well is to create objects at its actual scale. So here you see a pair of spectacles that a person has doodled with the 3Doodler. And what you can do is essentially put it onto your face, see if something's missing, if a bar is too long or short, sort of take it out and iterate upon the design. So we believe that this is kind of a key thing here, which is this testing and iterating mechanism, which helps you to speed up the process of designing. But there's a key limitation and a big question here. How do you do this for big objects or large-scale objects? Sort of the knee-jerk reaction to this will be, let's scale up the 3Doodler. But if you give it thought for a few seconds, you'll realize that there are key limitations to this. One of them being that just the amount of heat energy that you'll require to sort of fuse or cure this filament into a liquid form would require a huge battery, and that just kills the form factor of a handheld device. The second sort of key limitation is using so much plastic to create objects like a sofa would lead to a lot of weight, which again doesn't work well with something that you can have handheld and do quickly. So what do people do as a result? They sort of give up on scale, create a prototype small sofa, and they just hope that it's going to fit. But sometimes things don't work out that well. So that is sort of the problem that we're trying to solve with the Protopiper. So what it helps in is the physical sketching of real large objects at their actual scale. And there are two basic key ideas behind how this thing works. So for an input material, we take adhesive tape, which is sticky inherently, so you don't have to heat up or cure the filament. I mean, the stickiness of the tape also presented to us quite a few challenges, which we really enjoyed solving while building the device, while actually engineering the device, which we'll discuss about later. And the second key idea is to sort of make hollow tubes as the building material. So it's pretty light, but it's sturdy enough to make large objects that last. So the device is a bit like 3Doodler, as you can see, but but in a sense, it's very different as well. The Protopiper affords for creating straight lines. So it creates this efficient process of creating construction objects like this huge kitchen prototype that we created using the Protopiper, rather than just doodling in sort of small scale. So how does one build with the Protopiper? As you can see, the Protopiper affords for rectilinear connections. So one of the basic elements of building is a rectilinear box. It's a box, and you can create boxes of different sizes by just attaching some diagonal struts, a mechanism that we came up with to reinforce them, and allowing for creating, again, like prototypes like these. It's a combination of small and large boxes. So moving on, like one of the key design elements of this whole process is like all these things are based on one key design element, which is what we call the wing connector. So as you can see, the wing connector is essentially a clever way or a clever mechanism of cutting out the end of the tube so that it creates these two flaps which are sticky on the inside. And these flaps allow for attaching these tubes to different things. You can attach using the flaps, you open them up to attach them to the wall, or you can just close these flaps to attach to other tubes. So basically, it's just a universal connector that allows for connections of all kinds of things. So it is, as you can see, a very key element in this whole design process. Here you see that in action. Okay, so the wing connector allows for almost like 70 to 80% of designs, but we thought of adding more elements to sort of expand the design space of what can be created. So this is a hinge element. It essentially allows you to make odd angles in 2D, so you can create sort of more freeform objects, both in 2D like this, as well as in 3D. So it essentially adds to the organic nature of what you can create. Most of the objects that we saw till now are sort of static in nature. Moving on, we added mechanisms to the design primitives of Protopiper to create more movable objects. Here's an example of a sliding mechanism. So you can actually create a drawer that goes in, comes out, fully functional. And you can test if it's hitting something, if it's colliding with something. So it's basically this blue box confined within the green outer box, which allows for easy and smooth sliding in and sliding out. And we repurposed the hinge mechanism to sort of create rotations based on that. So here's how you can create a door that can be opened and closed. On top, you see the living hinges which provide for that. Sort of the second way of creating a rotation mechanism is just taking the wing connector and folding one side of it inside. So you can use the other side to create a more easily working door. Here for an oven example. And sort of the third and most sophisticated way of creating these rotations is through a bearing and axle mechanism. So we create a small triangle which acts as the bearing, and the door slides into it, which can be rotated and closed. And how do we close this door, and how do we keep it closed for a long time? Well, we create a door latch. The door latch is again created on using a hinge mechanism. So you can see the little zigzag line there. And zooming into that, the door just rests on that and stays shut. So this is an example of a pretty complex object, the umbrella, which is fully functional, and it can be made by combining all these mechanisms together.
All right, so until now you see what you can do with the Protopiper. Let me show you now how the device works. So this is how it looks like. I guess yesterday most of you have seen it. So, and this is what it does. It folds the tape into tubes, cuts it, and makes the wing connectors. So basically the device is a an assembly line. It pulls the tape off from the roll, curls it up, seals it, cuts it, and at the end of the process we have the tubes ready for use. So here is a close-up. You can see on the right side there is a tape roll, and the first element is a prong with a roller, which just makes sure that the tape comes off from the roll easily. Then it goes through the U stencil, which curves out the tape into the initial U shape, and after that, finally the E stencil aligns the two edges of the tape for sealing it together for a tube. So here is a close-up of these stencils, which we engineered through a couple of iterations. And you can see the rippled side of the inner side of these openings. And this is very important because the tape is sticky on the inner side, and it was a challenge to handle this stickiness. Okay, and the next stage, when the tape is curled up, then we have to steel it together, and that's happening with these two gears which are pressing it together. And there is two more stuff that is happening here at this stage. The gears are actually actuated with the servo motor, which is on the left side, and this pulls the whole tape off from the roll. And there is also an encoder built in the motor, so we can produce tapes from the exact length. And the next stage, when we have the tubes, then we have to cut it. And to produce these wing connectors, we created this special cutting pattern, which is shown on the left upper corner. And this is cut with these hot wire cuffs. And this is how it's happening. It's easier to see. And obviously, it produces a lot of smoke. So at the end of the device, there is just a hinging square, which makes it easy to fold the tubes into living hinges in exact 90-degree angles. And the whole device is controlled with an Arduino Nano, which controls the servo motors, the cutting wires, and there is a little bit of more logic inside, which speeds up the frequently used operations. So let's see how we operate with the device. There are two buttons and one dial, the extrusion button, the cut button, and the presets dial, and also a display which shows you the extruded length of the tube in centimeters. So the extrusion button is the most straightforward. As long as you are pressing the button, the tube gets extruded. The cut button can create three types of tube endings. The straight cut, when we don't need a wing connector, we just cut it straight. Then we can do the regular wing connector, and we can also just align the tape with the tube with the hinging square at the end to create the living hinge. And there are also more functionality in the device. We can store up to 3 tube lengths, which is particularly useful when we are creating boxes and cuboid objects, when we have to reproduce the exact same side lengths multiple times. And then we can recall these side lengths by double pressing the extrude button. And the device can also calculate the diagonals to reinforce these tubes. All right, and to verify our design, we also conducted a user study where we asked participants to design objects for an imaginary beach party, where we wanted to see if they can use the device to create objects according to their body. So this participant created a bar pulled to his own body height to be able to sit there all night long comfortably. Then these participants made a deck chair and the sun hat, where the sun hat was made on the head of the participants to fit from the beginning. This couple made a volleyball field with a net which was placed and at the height where they felt comfortable to play with. This is a little bit maybe harder to see. Sand castle, which is an example for freeform fabrication. And this is supposed to be a surfboard, but it turned out a little bit short. But we can forgive this because Berlin is a couple of thousands of miles from the closest surfable coast. So these participants were never surfing before. So at the end of the day, 16 participants used the device, and they rated it for being helpful for creative expression, 5.8 score from 7. They give very high score for being fun to use, and they also said that it helps to judge the right size of the objects at the end. So to conclude, Protopiper is a device for physically sketching large-scale objects at actual scale, and it does it by folding adhesive tape into tubes, which gives us a good strength-to-weight ratio, and because we do not need to heat up and cool down large amounts of materials, it can be a handheld device. So in the whole, with this project, we wanted to support the earlier stages of the design process. So in HCI, we have seen many projects where we sped up the CAD design, made it easier for use. Then we had projects where when we tried to interact directly with the machines, bypassing the CAD design process, the phase. And with this project, we wanted to support the very early stage of the design process, the sketching. And at the end, I would like to thanks to my collaborators, Udayan, Tim, Johannes, Stefanie, and our advisor, Patrick Baudisch. And who knows, maybe you will be the next collaborator on our next paper. Thank you for your attention, and we are happy to take your questions.
Okay, we have time for some questions. Please remember your name and affiliation.
Hi, my name is Diogo from Purdue University. I'd like just to ask you to talk a little bit about the battery life, and also about the hot wires. Do you guys think on maybe changing, maybe improving this type of cutting the end of the tube in the future work?
Yes, so we have experimented very much with the cutting mechanism. We also tried out blade cutters and also laser, but at the end this hot wire turned out the most efficient. And regarding to the battery life, it allows this small battery for 200 or 300 cuts. So it's pretty much enough for a whole day long session.
Steve Feiner, Columbia University. So really neat work. I like that little thing you made to stick on my glass last night. This impresses me as being very much a complement to the work in the previous paper, in the sense that you're making things that are more permanent and that don't require people to be holding up and moving around. So one question is, have you considered using this in conjunction with head-worn displays so that a person could, for example, make a mock-up of the kitchen like what you showed and then see it looking like a real kitchen, yet have some semi-permanent haptic feedback to get a sense of how they can walk around in that environment?
Can I ask our next speaker just to set up while they answer?
So absolutely, we were thinking about combining this approach with virtual reality, and yeah, that's part of the future work what we plan to do.
Or you didn't give instructions to multiple people using multiple copies to make things in parallel rather than on their own.
Yeah.
Thank you.
There.
From the Max Planck Institute. So it's great work. It looks like such a fun device to use. And live demo. Okay. I had a question. So once you're finished with the sketch, maybe you can make this solid, because I mean the lightweight character is somehow a feature, but when you're done with the sketching, maybe you want to really have the thing. So have you thought about like filling up the solid structure with some material that makes it solid, not concrete, but maybe something well lighter? Yeah.
Harshit,
I mean, we tried a few things, like we tried to fill it with foam, but I mean, all these things sort of lose the nature of the real-timeness of the whole thing. Foam takes some time to set and stuff like that, becomes a little messy. Air, just filling it with air is another option. So we have explored quite a few of these, but yeah, maybe in sort of the next iteration of these. But right now we've mostly stuck to the tubes.
Thanks.
Okay, I'll ask one last question. I enjoyed your contribution slide at the end. I thought that framed it very well to help people to understand how it places in the process. When you look at that process, though, how do you think you might modify this device in future to support moving on to the next stage of the process? I mean, moving from the sketching into the prototyping, et cetera.
Yeah, I mean, that's a good question. So we have looked at how can you sort of take this model and bring it into the computer, for example. Yeah, but I mean, that works, and it will work, but sort of the key idea behind this was just to make sure that the initial sketching process is something that can be done easily and quickly with people, and how can we sort of bring tech or bring sort of this device into that process, that initial process. But you're right, yeah, we can sort of take this back into the computer and play around with it a little more. Yeah.
There are two prototypes of that, is that what you said?
The 1, 2, 3D catch thing, yeah, Autodesk.
We'll see it at UIST next year.